Okay, I'm going to talk to you a little bit about dimensional analysis, and then we're going to do some dimensional analysis practice, because this is something that it's really critical that you learn how to do properly, because it's something we use in chemistry a lot. We tackle most problems using dimensional analysis, at least problems that involve any type of calculation. Usually, even if you don't understand kind of what's going on, how you would possibly go from, one thing to another. If you rely on dimensional analysis, it usually will lead the way. Okay. So in dimensional analysis, what's really important is being able to develop unit factors, okay? To use, unit factors to then lead the way, okay? And a unit factor is simply a fraction, okay? And it's a fraction that contains equivalent values, okay? Now, those equivalent values can be things that are equivalent always, or they could actually be things that are equivalent for a particular process you're doing. So like a chemical reaction. It can relate reactants to products or something. But right now we'll look at things that are truly just equivalent things. And so there's lots of these things that you may not even realize that you already know, okay? So I've got several examples here. And some of these you probably already know, right? Like a minute has 60 seconds in it, right? And so 1 minute equals 60 seconds. Those things are equal. And so if 1 minute equals 60 seconds, then we can just take those things that are equal and write them as fractions. And you can write it in either direction. So I've written it as 1 minute over 60 seconds and also as 60 seconds over 1 minute. Okay, so I can use that relationship in either way to do what I want. Okay, and so I would use that relationship to either convert from minutes to seconds or from seconds to minutes. Okay, and I would use the one that does what I want. Okay, and so we'll utilize these unit factors that relate equivalent things to do dimensional analysis. Okay, and so there's several more. Like I said, some of these you probably already know, like this other one on to the right. 1 foot equals 12 inches, right? That's not something that you would have to look up. That's just something that you know, or I would assume almost everyone does. And so that equivalence, we just rewrite as a fraction, and we can utilize it to do conversions, okay? And then I've got some, ones that you may not know here, that we have 1 inch equals 2.54 centimeters. And so that's a way to convert between the English system of length and the metric system of length. It's a pretty common one we use in chemistry. And so I have the unit factors written there. Another one you may not be familiar with, but it can be useful, is 1 pound is 453.6 grams. Okay, and so we can convert between mass in a English unit, which really, yes, I know pounds if you're a physicist, is weight. That's okay. We're going to call it mass. And then we have grams, which is our metric unit. Okay. And then I've got a couple metric examples down here on the bottom, because 1 kilogram is equal to 10 to the 3rd grams. So I can write that relationship as a fraction in both ways, with either the kilograms on top or the grams on top. And then I have another one with 1 meter equals 10 to the 9th nanometers. Okay, and so you can write that as a fraction either way. Okay? So these last two, those are dealing with metric prefixes. And so you either need to have kind of a table of metric prefixes handy when you're doing calculations, or you need to commit some of these, at least the most common ones, to memory. You need to be able to utilize them properly. And so I like to do it with all positive values. So always putting a 1 with the big thing and a positive exponent with the small thing. So here we've got a kilogram equals 10 to the third grams because kilo is a big thing. So one of those has a lot of the small thing. And I know kilo is related to 3. Okay. Whereas nano is a small thing. So there should be a lot of those in the base unit. And nano is related to 9. If you use typical scientific, or if you use typical metric prefix tables, it'll tell you that nano's 10 to the negative 9th, and that means that there's 10 to the negative 9th of a base unit in one of that prefix, okay? So those are 2 ways you could write that. I just like to write it with positive value. It would give you the same results, whichever one you decide to use to build your unit factor and to do dimensional analysis. But using the negatives, I've seen a lot of people make mistakes, so I usually don't use those. Okay, so unit factors are kind of the core. You've got to be able to write unit factors to do dimensional analysis because that's what you're going to utilize. So in dimensional analysis, we are converting units, basically. That's what you're doing. You have some value that has a certain unit, okay? Some initial unit of whatever your measurement is. And there's some other unit you want, okay? And so how you convert from this initial unit to the unit you want is you multiply by a unit factor. Okay, and that unit factor is going to be a fraction with 1 unit on top and a different unit on bottom, and you're going to set it up to where the units will cancel, okay? So my initial unit, the unit that I want to get rid of is on the top, okay, or a standalone unit. Then I'm going to put that same unit on the bottom. I'm going to put it opposite so it cancels, okay? So when I multiply that fraction, the initial unit's going to cancel and it's going to give me that desired unit. Okay, so I set up dimensional analysis to cancel my units, to get rid of the things I don't want and give me the things I do. Okay, so if I have a measurement that is in centimeters, okay, and let's say I don't want centimeters, let's say I want meters, okay, if I want to convert my centimeters to meters, then I'm going to multiply by a ratio or a unit factor that has meters on top and centimeters on bottom. Because that's going to put the centimeter part, the part that I don't want, opposite. And it's going to cancel and leave me with meters. Okay, so those centimeters will cancel and give me meters. Now, of course, I'm showing this with no numbers. Okay, there would be numbers in front of each of these things, okay? But if you focus first on the units, that will help you set up the problem correctly, and it'll force you to do the right math, okay? So if we look at something a little more complicated, let's say we have a mile per gallon valve. So we know how many miles per gallon we get in our vehicle, okay? And let's say we want to convert that to kilometers per liter, okay? So to a different unit. Well, I can get rid of the miles, I can convert the miles to kilometers if I multiply by a unit factor that relates miles and kilometers, okay? And so I would put the miles opposite, I would put the miles on bottom so it cancels, and I would put the kilometers on top so that that's still there. And then I want to get rid of the gallons. And so I'm going to put gallons opposite of where it's at right now. Okay, so gallons is on the bottom. I'm going to put gallons on top. And the unit I want opposite of it. And so I want liters. And so then that would result in a value in kilometers per liter. Okay, and so the first one's going to multiplying that first unit factor cancels my miles. And multiplying by the second one cancels my gallons. And it gives me the unit that I want, okay? So a lot of times when you're doing chemistry problems, focus on the units and look at what am I starting with and what am I trying to get to? And is there a way I can just multiply by fractions to cancel units that I have and give me units that I want? Okay. And so let's do some unit conversions. Okay. Just basic unit conversions using dimensional analysis. Okay. Now, some of these you might be able to just do in your head. And that's fine and all, but that's not the point of this right now. You want to learn how to do dimensional analysis because it's a very useful tool in chemistry. So here I've got some English. These are all in English units. Well, I guess they're not all, they all involve some English units. The one is converting to English units, I guess. So here we're actually converting between English and metric, I should say. So the first one, let's just start with this first one, number 1, okay? That one, we say how many grams are in 8 pounds? So I have 8.0 pounds. That's what I know, okay? And I want to convert that value, okay? I want to convert it to grams. So I'm going to focus on units first. Don't worry about numbers to start with, because if you do, you are likely to mess it up, or you got kind of a 50-50 shot if you focus on numbers first. So I have pounds, and that's really on the top. So if it helps you, you can write that over 1, okay? And so I'm going to put pounds on the bottom, and I'm going to put grams on the top. And what that's going to do is that's going to cancel my pounds and give me grams in the end. So now I want to do the calculation. So I need to fill numbers in. So that means I either need to know off the top of my head, which you really don't need to know off the top of your head, or I need to look this up. Now, sometimes when people ask you questions like this, they give you the relationship. So if you look this up, since I didn't give it to you, what you should find in a table of unit relationships is that there are 453.6 grams in 1 pound. That was actually one of the ones I gave on the unit factor slide as well. And so that's your relationship. So when you multiply that, that is going to cancel pounds and give you grams, okay? And so let me punch that in my calculator and see what it gives me. So I have 8.0 times 453.6 divided by 1. And that, what the calculator tells me at least, is 3628.8 grams. Okay. Now that is not what I report because that is not the correct sig figs. Okay. So here you would need to look at this and say 8.0 pounds, that's 2 sig figs. Okay. Whereas this relationship, since it's between 2 different measurement systems, English and metric, it actually isn't exact. Most of the time those aren't. But if you're going from an English unit to an English or a metric to a metric, those relationships are definitely exact. In this case, it's not exact. And so this is really a 4 sig fig now. Okay, now I'm doing a multiplication, so I focus on 2 sig figs. And so the 3 is my first one, the 6 is my second one. So I look to the right of that, and there's a 2. So that isn't going to change the 6. And so my answer should be 3,600 grams. Okay, you can't drop those zeros because 3,628.8 can't become 36. That is senseless. Okay, so you have to keep those zeros as placeholders. If you would prefer, you can write it as 3.6 times 10 to the 3rd grams. Okay, then you don't have those zeros that's confusing you sig fig ones. Okay, you could do that. So either of those would be appropriate answers. Okay, now on to the next one. Let's do number 2. Okay, I want to know how many meters are in 25 yards. So I have 25 yards. Okay, and I don't want yards, so I put yards opposite. So remember, if it's a standalone value, it's really over 1. And then meters on top. Okay, that'll get my units where I need them. Now, again, this isn't a unit relationship that most people would expect you to know off the top of your head. And since it wasn't given, you'd have to look it up, which is generally easily done in a chemistry book. But I have it written down here. It's 0.9144 meters per 1 yard. Okay. And so that is going to cancel my yard units and give me a value in meters. So if I punch that in my calculator, 25 times 0.9144, then I get 22.86 meters, okay? And again, that is not what we're going to report in. We still have to do our sig fig analysis. So our units, the yards cancel, gives me meters. If I look at my sig figs, oops, I have 25. Oh, no, sorry. 25 is 2 sig figs, right? So work. It's going to work. Here we go. 2 sig figs. And then this, since it's between English and metric, I'll assume that's not exact. It's not. It's 4 sig figs. Okay, so the 2 sig figs is going to win out here again. So the 2 is significant. The 2 is significant. I look to the right. I have an 8. So, oops, the 2 is going to round up. Okay, so that gives me 23 meters as my answer. Okay. So here, this is the answer. That's the answer. Okay, to the appropriate number of significant figures. Okay, now let's do another one. We have got how many gallons are in 1.75 liters? 1.75 liters. And I don't want liters. Again, it's a standalone number, so it's really over 1. I put liters opposite. Since it's on the top, I put it on the bottom. And I want gallons, so I put gallons on top. And that, again, between English and metric, you probably don't have those memorized. You look it up on a table. If you look it up, what you'll find is 1 gallon is 3.785 liters, okay? And so that's going to cancel our liters and give us gallons. So I could take 1.75 and divide by 3.785. And so that's going to give me 0.462351387, which is completely ridiculous. You should not give answers like that, but I'm just writing down what the calculator tells me, okay? And then we're going to do our sig fig analysis. So if you analyze sig figs, you've got 3 sig figs here. And then since this is English metric, it generally is not exact. The only one that's exact is 1 centimeter, or sorry, 1 inch is 2.54 centimeters exact. Any other metric to English conversion is not exact. So this one's 4 sig figs as well. Okay, and so 3 sig figs is the lowest. So I'm going to round my answer to 3 sig figs. The 4, the 6, and 2 are significant. Remember, leading zeros are not significant ever. So then I look to the right of that 2, and there's a 3, so it doesn't change the 2. So my answer should be 0.462 gallons. Answer to the correct number of significant figures. Okay, now next up, we've got convert 3.65 pounds per gallon to grams per liter. So I have 3.65 pounds per gallon. It is helpful to write that as an actual fraction instead of this slash. So I'm writing 3.65 pounds per 1 gallon, just to make this a little more clear. It's a little easier to see how dimensional analysis is going to work, because the gallons is on bottom. Now, I don't want pounds, so I'm going to put pounds opposite, and I want grams, right? I don't want pounds per gallon, I want grams per liter. So the pounds needs to change to grams, and then the gallons needs to change to liters. So I'm going to focus on units first again. So the gallons I'm going to put on top to cancel, and liters opposite, okay? And so that is going to give me the units I want in the end, okay? And then I can look up these relationships. Since they're not given here, I'd have to look them up. We used this earlier, the 453.6 grams per 1 pound. If you don't know it and it's not given, you look it up. And then relating gallons to liters, 1 gallon is 3.785. We also used that earlier. Now we can look at our units and make sure we actually have it set up right. Really, you should look at that probably before you even write the numbers. So the pounds cancel, the gallons cancel, right? And we're left with grams per liter. Great. Okay, so now that, if we punch that in the calculator, let's see what that gives us. 3.65 times 453.6 and divided by 3.785. That gives me, at least the calculator tells me, 437.4214003, and that would be grams per liter. Okay. But again, we don't want to report this crazy number. Okay, and you're also really never told round to this many decimal places or round to this many sig figs. You're just supposed to know. Okay, so if we look at our sig figs, we have got, for this first one, 3 sig figs, right? The second one is 4 sig figs. And this one is 4 sig figs. So we're going to round to 3 sig figs in the end. And so the 4 is significant, the 3, the 7, and if you look to the right of the 7, you have a 4, so that's not going to affect it. So you would have 437 grams per liter. Oops. There we go. Good enough. Okay. Okay. So those were all, involving English units. Now, most of the time in chemistry, you're dealing with metric units and metric units only a lot of the times. So let's focus on some metric conversions. So if we do that, first I've got a couple of hopefully simple ones. First I want to convert between 807 centimeters to meters. Okay, so number one, we have 807 centimeters, and again, that since it's standalone, it's really over 1. And so centimeters, I'm going to put opposite so it'll cancel. And then I'm going to put what I want in the remaining slot. So meters. And then since this is a metric prefix conversion, so it's a number with a prefix to one without, then you should most of the time be able to just come up with those unit factors off the head, out of your head instead of looking up, but you could. So usually what I would say is, okay, which one's bigger, meter or centimeter? Well, meter's bigger. So one of those has a bunch of the centimeters. And so then it's 10 to some power of centimeters. And then all I need to know is what does centi relate to? Well, centi relates to 2, okay? And so that then would give me my answer. And if I divide by 10 to the second, I get 8.07 meters. Okay, that's my answer. And usually with these, you don't have to stress so much about sig figs because you're just shifting decimals. So this is 3 sig figs. This is exact. So this would have an infinite number of sig figs. And so the 3 sig figs is what we should have in the end, which is what we have. Okay, so that is the correct answer. Then let's see, number 2, convert 4.0, kilograms to grams. So again, it's a standalone number, so I can write that over 1 if that helps you see what's going on. And then, this isn't cooperating. We can put kilograms opposite, right? So it'll cancel, and put grams, what we want, in the opening. And so then with that, again, this is a metric base unit and prefix. And so I just can think about which one's bigger, grams or kilograms. Well, kilograms are bigger, so one of those has a bunch of the small things. So 10 to some power, and that power is dependent on the prefix. So kilo is 3, so 10 to the third grams in a kilogram. Okay, and so then that means that I have 4,000 grams. Okay, or since this looks a little confusing because this is like, what is it, 1 sig fig? Okay, or that's what, maybe I should write this so you can see it a little better in a different color. And so this, if you report that, some people might think it's 1 sig fig. Okay, and so we don't know if it's 1, if it's 2, if it's 3, or if it's 4. Okay, but based on what we use, this is 2 sig figs, and this is infinite because it's an exact conversion. So really, the answer is 4.0 times 10 to the third grams, which makes it very clear that it's 2 sig figs. Okay, it's not 1 sig fig. So really, this 0 is significant, but the others are not. Okay. So that's why scientific notation can be good, because you're a little clearer about your sig figs. Okay, next up, let's do one more with metric prefixes. Actually, did I miss one? No, I didn't. Okay, well, there we go. So here I say convert 1.862 grams per cubic centimeter to kilograms per meter cubed. Okay, so we have, whoops, 1.862 grams per cubic centimeter. So again, I'm going to just rewrite this as a regular type fraction. Okay, so it's easier to see what's going on. And we want kilograms per meter cubed. So I don't want grams, I want kilograms. So I'm going to put grams, and I'm going to put kilograms, so that the grams cancels and gives me kilograms. And then I don't want cubic centimeters. Right, so I'm going to put that opposite. I want cubic meters. Okay. Now that tends to confuse people because we usually don't know a relationship between cubic units. So it can be helpful to, instead of writing that, say we don't want centimeters, we want meters, and really you need to cube that. So essentially you're taking centimeters per meter times centimeters per meter times centimeters per meter. And that is going to cancel out this centimeters cubed, because that is really centimeters times centimeters times centimeters. So you're doing a conversion, we know, a relationship between centimeters and meters 3 times, okay? And so usually it's best to either write it as a cubed conversion, okay, or to write it 3 times, okay, whichever helps you. So I have the basic layout of my dimensional analysis here. I need to fill in my numbers. So since these are metric conversions, let's do this. Which one's bigger, kilograms or grams? A kilogram's bigger, so one of those is a lot of grams. And how I know is kilo is 3, so it's 10 to the third grams in a kilogram. Okay, and then centimeters and meters, which one's bigger? Well, a meter is bigger, so one of those has a lot of the small thing, and how many is dependent on that prefix. So centi is 2, so it's 10 to the second centimeters in a meter. Okay, and so you can punch this in the calculator and get the result. Again, if this confuses you, taking 10 to the second centimeters per meter, cubing it, you could write that 3 times. So you could write times 10 to the second centimeters per 1 meter times 10 to the second centimeters per meter times 10 to the second centimeters per 1 meter. That's the same thing. You write that 3 times or you say that's cubed. You just make sure that you actually type it in your calculator as that value cubed. So we have 1.862, and what we divide it by 10 to the third. I should probably be doing this in my head as well since it's just factors of 10, but I'll be lazy and just do it this way. And let's see, looks like if I didn't do something crazy, which no, it's 1862, sorry, kilograms per meter cubed. That's the answer. Okay, oops. Good. So if we go back and make sure, look at your units, your grams cancel, your centimeters cubed cancels with this centimeters because it is cubed. Okay, it gives you kilograms per meter cubed. And so that is our answer. And it is 4 sig figs because this is 4 sig figs and everything else is exact. Okay. Now, one other thing that sometimes trips people up is when you're dealing with metric prefixes, sometimes you'll want to convert from one prefix to another prefix. And your table of information about metric prefixes never tells you about that. So it doesn't tell you how, say, milli relates to micro. You know, you can derive it from those tables. People tend to mess it up. So if you're ever dealing with multiple prefixes, you're best off going to the base unit in between. Okay, so that's something that, you know, when it comes up in examples, that's what you'll always see me doing. But I think that's enough practice there. So that's something that you see in, you know, the calculations I do. Most of the time, I will do dimensional analysis. That's what's always going to be most helpful when you're doing chemistry.